All right, I got a feeling that there's something cool that's going to happen today. We have some general functions, and we're going to find their derivatives. So, for example, if I have a function c, suppose I have a function f of x is equal to 5. Somebody describe that function for me. F of x is equal to 5. What does that look like? Horizontal line passes through 5. What's the slope of that horizontal line? So if the derivative is the slope, what is the derivative going to be? So f prime of x in this situation will be 0. The derivative of any constant is 0. Any question? Let's consider the function x. What is always the slope of x? So the derivative of x is equal to 1. Everybody okay with that? Suppose I have a different kind of line. Suppose f of x is equal to negative 3x. If you were to graph negative 3x, that would be a line as well, right? Only it would be a line that would, how is it different? There's a slope of negative 3. So the derivative tells me the slope. So the derivative is going to be? So f prime of x is equal to whatever constant is there. So whatever the slope is in front of x, that's the constant. That's going to be the derivative. So let's get to the big idea right here, and that's f of x equal to x to the nth. You guys did some amazing work the other day. It was absolutely awesome. I saw you take f of x is equal to like x to the 5th. Do you remember that? And we said, well, I want to find f prime of x, and that's going to be the limit as h goes to 0 of f of x plus h minus f of x all over h. Remember we did all that? We had to like use the binomial expansion thing of Pascal's triangle, and we had to do all that work, and we ended up coming up with something in the end. But we were able to figure it out, right? Well, so what if it was x to the 58th? That would be a lot of work, wouldn't it?
There's a trick.
I bet there's a trick. So says Morgan. Thank you, Morgan. Let's find out what happens. We're going to derive the power rule, otherwise known as the derivative of the function f of x equals x to the nth, using this formal definition. F prime of x is equal to the limit as h goes to 0 of, and what I'm going to do is I'm going to take this function x, we talked about x raised to the 58th power. I don't want to actually expand it all that far, so I'm just going to write it, we're going to use a variable n. So as I type in x plus h, I'm going to have x plus h raised to the nth power. Minus my function, x to the nth, divided by h. Is anybody confused where those elements came from? Remember, you take the function and you put in x plus h, then you subtract the function and you divide by h. We all good? All right, here's where you need to think. The rest of it, you won't even need to think. It's that easy. That's the same as the limit as h goes to 0 of, we need to expand this. We need to expand this x plus h raised to the nth power. Who can tell me what is going to be the first term? X to the nth. Right? What would be the last term? H to the nth. Just trust me, okay? You're in good hands. Don't worry, I've done it before. Minus what? All over? No. So what I need is I need to, way to think ahead, but no, we're not going to get that. So I need to fill in some pieces there, don't I? I need to fill in some pieces there. And we will. So we're going to have then x to the n minus 1, right? Because it will go down by a power each time, right? So if we start off with x to the 5th, then it would be x to the 4th and x to the so on and so forth, right? But we're also going to pick up an h. Everybody agree with that? So I'll put h. And then the next term I would have x to the n minus 2 times h to the 2nd. And then after that I would have x to the n minus 3 times h to the 3rd. All the way until we get to an h to the nth. Now I'm missing my coefficients, aren't I? I'm missing my coefficients. And that's the last piece that we really have to be able to think through. I want you to follow this guy. If we have x plus y to the 0, x plus y, x plus y to the 1, x plus y to the 2nd, x plus y to the 3rd, x plus y to the 4th, and x plus y to the 5th. We've taught you how to expand all those, and we said that the coefficients in this case would be 1, and then 1, 1, then 1, 2, 1, then 1, 3, 3, 1, then 1, 4, 6, 4, 1, and then 1, 5, 10, 10, 5, 1. We're all good with those, right? What do you notice about the second term? It's the same as the exponent. Everybody see that? After that, we don't really know. We got to use a triangle. But the fact is that the second term always comes from the exponent, doesn't it? So, if I go back to my little dealie here, we know the coefficient for x to the n is simply going to be 1, right? We always start with that 1. What will the coefficient be for the next one? What's my power? N. After that, we don't know what constant we're going to get, so I'll just put c sub 1. And after that, I'll put c sub 2. We'll just start gathering some kind of constants, whatever, you know. And there's the expansion. So let's see if you now notice. Don't look upset. It's going to be beautiful. Okay, it's going to be great. What happens? What happens? What cancels? What are, there's only two things up there that don't have an H. Everybody agree that those cancel? And everything that's left has an H. So I could factor an H out of the top, correct? So let's factor an H out. So I get the limit as H goes to 0 of, what is this? If I factor an H out, what is that green term going to look like? X to the n, or I'm sorry, n times x to the n minus 1. N times x to the n minus 1. And then the H is out front, right? How about the next term? What's that going to look like? Yeah, c sub 1 times x to the n minus 2 times h. Now, I don't know if anybody heard Leon say something, but he said whatever is going to be there is going to have an h. And he noticed that because he said, well, if it has an h, it's just going to cancel out anyway. So we'll do the math so you can see it, but the next one would be c sub 2 times x to the n minus 3 times h squared. And Leon is saying it doesn't really matter because they all have an h. They're just going to disappear anyways. What's that last term going to be? H to the n minus 1, which we don't really care about, do we? Because it's just going to go to 0 anyway. This is all over h. So what happens? The h is canceled. Can I now plug in 0? As you plug in 0, what's going to happen here? Gone. How about here? Gone. How about here? And you're going to end up with this left over, right? So therefore, the derivative is equal to n times x to the n minus 1. It's that simple. So right now, some of you are saying, I don't even know what I just did. And I'll show you. Suppose our function is equal to x to the 5th. If you want to know the derivative, it is this simple. Watch. Take the exponent, drop it in front, and subtract 1 from the exponent. So you get 5x to the 4th. Done. Oh, you don't believe me? I'll try it again. F of x is equal to the 100th. We'll say f prime of x is then we take the exponent and move it in front, and then we lower it by 1 power.
Why are they related? What?
So you get it both ways.
Watch. If you have a multiplier out front, you just drop the 5 in front, it will be 15x to the 4th. Look at how fast that happens. So on this test, right now you're asking yourself, do you have to do the limit as h goes 0 of f of x plus h minus f of x all over h? Do you have to do that? And the answer is, on this test, you need to do this, and you will not have to use it again. You will, after this point, after this test, you will always just be able to do that rule. And we'll make it quick. Flip it over and let's try some examples. I would like to show you this 2 ways so that we all understand. And folks, we're going to practice during this time. Let's see how the rule works in this situation. Remember, the rule says if f of x is equal to x to the nth, then f prime of x, again, this is the power rule, is n times x to the n minus 1. That's the rule we're going to use. You drop the exponent in front and subtract 1 from the exponent. So let's just think about it for a second. We already talked about what is the derivative of a constant. 0, because that slope is always 0. Let's look at it from the power rule. So you'll never actually do it this way. I just want you to see how it works. This is like 5x to the 0 power, because anything to the 0 is 1. So watch what happens when you drop the 0 in front. You get 0 times 5 to the x minus 1. And 0 times anything is 0. Even if it's negative, the derivative of a constant is still 0. F of x is equal to 4 to the x power. Okay? Anybody know what the derivative is? It is 4. Remember, it's like a line with a slope of 4. That's how I think of it. Here's another way that I could write it. 4x to the first. If you drop the 1 out front, you get 1 times 4x to the 0 power. What's anything to the 0? Times 4 times 1. So you can see it will always work out. Letter D, you can actually take the derivative of each piece. So, what is the derivative of negative 3x? Negative 3. What's the derivative of 5? 0. So you're done. Remember how much time this would take us if we were to plug it into our formal definition. Limit as h goes 0 of f of x plus h minus f of x all over h. What's the derivative of 5x squared? Drop the 2 in front and you will get 10x minus, what's the derivative of 10x? 10. What's the derivative of negative 3? So you're done. Oh, sorry. Okay, right up here, Morgan. Do you see how the derivative of a constant is 0?
Okay.
That's a constant.
Okay.
So we're not supposed to do this on the test?
You will have this on the test. You will also have the limit as h goes to 0. So my friend Annika, she said, Mr. Gens, is there a way I can check to see if the derivative of that is that on the test? So if I ask you to use the formal definition there, you know ahead of time you should be coming up with 10x minus 10, right? Yeah. Or I'm sorry, 10x plus 10. Okay, we're going to jump back to these problems, but first I want to turn to letter K. Can you imagine if we used limit as h goes to 0 of f of x plus h minus f of x all over h? Can you imagine that?
1, 9, 4, 3, 7, 8, 9.
Now, what do you think, how much time do you think it would take us to do that? Look, okay, we'll say an hour, all right? All right, Morgan, you time us. You tell me when to get ready, and we'll go, okay? You tell me when.
Right now?
Yeah, you time us.
Okay. Wait. You gotta wait till it gets. Okay, go.
What's the derivative of 2x to the 7th?
14x to the 6th.
14x to 6 minus
18x to the 5th.
18x to the 5th plus the derivative of 2x to the 5th is
10x to the 4th.
10x to the 4th
Times 4x to the 3rd.
minus 4x to the 3rd. Derivative of x cubed will be
3x squared.
3x squared. Derivative of 6x squared, 12x. And the derivative of negative 10x. And the derivative of a constant is always 0. Morgan, what time are we at? How long did that take us?
Yeah. 40.
Took us about 40 seconds. And after some practice, you guys agree we could drop that down to about probably 15 seconds? I think so. So we took something that would normally take us an hour and we've reduced it significantly. So it works out quite well. Now you've seen the example work quite nicely. Let's try ones that are slightly trickier. What's different about letter F?
You got the fraction and a got the rest.
Yeah, it's got, so what we have to do is we have to write it as an exponent. So I'm first going to write it as f of x is equal to 8x to the 5th minus 3x cubed. Anybody know how I'm going to write 1 over x squared? Isn't 1 over x squared the same as x to the negative 2? So that's what you struggle with on the test, is rewriting in that form. Minus, can somebody tell me what the square root of x would be? X to the 1/2. So, notice, did I just take the derivative? No, I just rewrote it. Notice in my work here, I just wrote f of x. So now I'll take the derivative. What do you think I write to show I'm taking the derivative? F prime of x. All right, let's make this nice and easy. Derivative of 8x to the 5th. 40x to the 4th. 9x squared. Derivative of x to the negative 2. Negative 2, x to the negative 3. We have to subtract 1. We go down 1.
Wait.
I'm waiting.
How did you get the negative 3?
Negative 2 minus 1 is negative 3.
Okay.
Better?
Yeah.
Minus 1/2 x to the negative 1/2. 1/2 minus 1 is negative 1/2. Can we leave our answer with negative exponents? No. So again, we have the derivative, which is our 40x to the 4th, minus our 9x squared, minus 2 over x cubed. And notice x to the negative 1/2, I'm going to write it like this, minus 1 over 2, and a square root of x. Or you could put x to the 1/2 either way. Are you okay with that? Okay, anybody know how I write the exponent for the cubed root of x to the fifth? That's x to what power? 5/3, very good. So you can see that whatever is above the x, that stays there. The index for the root, that goes to the denominator. That's how that works. So in other words, f of x is negative 3x to the negative 5/3. So I've just rewritten it. Now I'm going to take the derivative. As you take the derivative, you have to multiply negative 3 by what? Negative 5/3. What's negative 3 times negative 5/3? 5. What do we do to the exponent? We subtract 1. What is negative 5/3 minus 1? Negative 8/3. Very good. So unless it's a square root, I generally like to write my answer as 5 over x to the 8/3. I don't like to put it back into radical form. I really don't. And the AP exam, I believe, will put the answer like that as well. So you try letter H on your own, you smarty pants. I'm slowly working through this one. Question? Yeah. So what do I do with this 6 over 7? I drop it in front. So it's 6 over 7 times negative 2 over 5. What do I have to do to my exponent? I subtract 1. 6/7 minus 1 would be negative 1/7. So now I have this, and now that I have this, I'll go ahead and put it into simpler form. 6 times negative 2 is negative 12. 7 times 5 is 35. And the negative 1/7, I have to drop that to the denominator. Better? What's different about the next one? Can everybody see how people would be tempted to just drop the negative 2 in front? Can't do that. It must be written as a constant times x to a power. It has to be written in that form. The parentheses are not allowed. You must get rid of the parentheses. So let's talk about getting rid of those parentheses. I want to get rid of this negative on the 2. How do I get rid of this negative on the 2? Yeah, you flip it. So would everybody agree this would be negative 3 over x squared? Okay, now I'm going to get rid of the squared. What's that? Yeah, so this thing right there, that 1/3 x is the same as x over 3, so I flipped it. Now I'm going to square it, and I have f of x is equal to negative, what? 9 over x squared. Great. Can I now write that as a power? That'll be negative 9 times x to the negative 2. Have I taken the derivative yet? No, I've only rewritten it. Let's take the derivative. Good. Negative 2 times negative 9 is 18, and we subtract 1 from the exponent. Can I leave my answer like that? Nope, so it's 18 over x cubed. That's the derivative. One last problem. Flip it over. What about letter J? That's no good, is it?
No.
Nope, it's not. Let's rewrite it. F of x is equal to, this is the square root of a quantity. I'm going to rewrite it as the square root of 5, that's my constant, times x to the 1/2 power. Are you okay with that? Minus the square root of 3. The square root of 3 is just a constant, isn't it? What's the derivative of a constant? 0. So does everybody agree that the square root of 3 is just going to disappear? All right, and then the root of x, I could rewrite that as x to the... Great. So now that we have it rewritten in a form, we have a constant times x to a power. Let's go about our business. F prime of x is, what do I do? Drop the 1/2 in front, right? It'll put a 2 in the bottom, but I'll raise 1/2 times the root of 5 times x to the negative 1/2. What's the derivative of the square root of 3? 0. Plus x to the 1/2. What's going to be the derivative of x to the 1/2? 1/2 x to the negative 1/2. Not too bad here. Can anybody see from this expression what's going to be in the top? The square root of 5 is in the top. What's in the bottom? 2 times x to the 1/2, or 2 roots of x. Plus, what's in the numerator here? Just 1, and the denominator? Again, 2 roots of x, right? Those actually have common denominators, don't they? So I'll just finish this off by writing it as the root of 5 plus 1 over 2 roots of x. That is the derivative. So I think everybody could see that as you add positive and negative exponents of radicals, it could get slightly more challenging, right? Turn to your worksheet and try some of those problems.